Today, we're going to explore the fascinating process behind the formation of relief rainfall, a common occurrence in certain geographical areas. It may seem complex, but I'll break it down into some easy to follow steps. Step 1 is warm, moist air rising. Relief rainfall occurs when warm, moist air is forced to rise over a mountain or hill. This usually happens when prevailing winds bring air towards a mountain range. Step 2 is then cooling and condensing. As the air rises, it cools. The higher it goes, the cooler the air becomes. This cooling causes the water vapor in the air to condense into tiny water droplets, forming clouds. Step 3 is then cloud formation. The process of condensation releases latent heat, which helps the air to rise even further. As more and more water vapor condenses, the clouds grow larger and denser. Step 4 is then precipitation. When the clouds can no longer hold the condensed water, precipitation occurs. This can be in the form of rain, snow, or sleet, depending on the temperature. The windward side of the mountain, where the air rises, receives the most precipitation. Step 5 is in the rain shadow effect. Once the air has passed over the mountain, it descends on the leeward side. As it descends, it warms up and becomes drier. This area receives much less precipitation and is known as the rain shadow area. Next time you experience rainfall in a mountainous area, remember the incredible atmospheric processes that contribute to this phenomenon. Today, we're going to explore frontal rainfall, a type of rain that occurs when two different air masses meet. It is especially common in the UK and other temperate regions. Let me break it down into some simple, easy to follow steps. Frontal rainfall happens when a warm air mass meets a cold air mass. These two air masses have different temperatures and densities, and as such, they don't mix easily. Where they then meet is called the front, and this is where the rainfall occurs. Because warm air is lighter and less dense, it is forced to rise over the heavier, denser, cold air. As it rises, the warm air begins to cool down, and this is the process that sets off the rainfall. As the rising air cools, the water vapor condenses into tiny droplets, forming clouds. The type of cloud formed depends on the type of front. Warm fronts create wide, layered stratus clouds that have the potential to bring steady rain, whereas a cold front creates tall cumulonimbus clouds, leading to heavier and more intense showers. When enough condensation occurs, precipitation falls as rain along the front. At a warm front, where a warm air mass moves towards and over a retreating cold air mass, rainfall tends to be gentle and prolonged, as the air rises slower and covers a larger area. At a cold front, which is when cold air masses move towards and under a warm air mass, rainfall is usually heavier but shorter, as the warm air is forced to rise quickly over the top. As the weather system moves, the front also moves, bringing changing weather conditions. After a warm front passes, the air feels milder. After a cold front, temperatures drop and the weather becomes clearer. So now you know how frontal rainfall forms. When warm and cold air masses meet, the warm air rises, cools, condenses, and produces rain. The next time you see a grey, rainy day sweeping across the UK, you can bet it is caused by a front moving through the atmosphere. Today, we're going to explore convectional rainfall, a type of rainfall commonly experienced in hot climates and during summer months in temperate regions. It might sound complicated, but I'll break it down into some easy to follow steps. Step 1 is intense heating of the Earth's surface. Convectional rainfall occurs when the sun heats the Earth's surface, particularly in tropical regions and during summer in temperate zones. This intense heating warms up the air near the surface. Step 2, warm air rises. As the ground heats up, the warm air above it expands and becomes less dense. This causes it to rise quickly in strong convection currents. Step 3, cooling and condensing. As the warm air rises, it cools down. The higher it goes, the lower the temperature. When it's cool enough, the water vapor in the air condenses into tiny water droplets, forming clouds. Step 4, cloud formation. As condensation continues, large clouds begin to form. In convectional rainfall, these clouds are often towering cumulonimbus clouds, which can bring heavy rainfall and even thunderstorms. Step 5, heavy rainfall and thunderstorms. Once the clouds become saturated with moisture, precipitation occurs in the form of heavy rain. Because convectional rainfall results from intense heating, it often happens in the afternoon when temperatures are at their highest. In some cases, the rapid rising of warm air can lead to thunderstorms. Now that you know how convectional rainfall forms and why it is so common in tropical regions, next time you see a heavy, sudden downpour on a warm afternoon, you'll understand the powerful forces at play in the atmosphere.